One of the ways that we can represent probability is by using a tree diagram. Within that tree diagram, each outcome branches off into the next set of outcomes. Tree diagrams are useful because they show each possible outcome for all the results that are needed. While creating the tree diagram can be time-consuming, it's worth it in the long run because you can answer any question that is asked based on the results shown. So let's use a tree diagram to answer the question. Sam has 3 pairs of pants, jeans, sweatpants, khakis, and 4 shirts, t-shirt, sweater, button-up, and sweatshirt. How many different combinations can he wear? To get us started, let's put headings for each branch of the tree diagram. Pants and shirts. Now let's start with pants, since that's the first branch of our tree diagram. Let's list jeans, sweatpants, and khakis. Now from there, we know that each pair of pants can be matched with each of the 4 shirt options. So from there, we're going to branch off under our column shirts, and we're going to list those 4 options for each of the pants. To answer the original question, which was how many different combinations can he wear, we look to the final branch in our column, which is shirts in this case, and we count the number of options there are. There are 4 that can be worn with jeans, 4 with sweatpants, and 4 with khakis, making the total number of outcomes or combinations 12. I said before one of the benefits of using the tree diagram was that you could see all possible combinations or outcomes in one picture. From here, we can answer any question that could be asked. For example, if we want to know how many different outfits he can wear with jeans, all you have to do is follow the first set of outcomes. If you want to know how many he can wear with sweatpants, you follow the second, and khakis for the third. Let's say it's chilly outside and Sam wants to wear a sweater or a sweatshirt. You can also follow the outcomes and figure out which ones would land with those outcomes. All of this information is gathered without even changing your original tree diagram. Another benefit to this tree diagram is that we can further branch out. Let's say Sam wants to pick different shoes. Let's say he has 2 options, sandals or runners. You can add a third column branching off for each one of those: jeans, t-shirt, jeans, sweater, jeans, button-up, jeans, sweatshirt, and the same for sweatpants and khakis.